Hello everyone, we are Group 17. In this presentation, we'll discuss solar energy as a fossil fuel alternative. Our presentation will discuss the introduction to solar energy at first, then we'll talk about land use and carbon dioxide emissions, and the feasibility in Australia, and finally doing a short summary. In the face of limited fossil energy sources and several global environmental problems, alternative energy sources have become one of the key solutions. Among them, solar energy is becoming an important tool for combating climate change and reducing carbon emissions. In recent years, the promotion of solar energy has been important for improving energy efficiency, reducing dependence on fossil fuels, and reducing carbon dioxide emissions. As shown in the picture, renewables accounted for about 30% of global installed capacity in 2016, providing nearly a quarter of global electricity generation. Solar power accounted for nearly 8% of renewable energy generation. As shown in the picture, solar photovoltaic is expected to account for about 25% of total electricity demand by 2050. How does solar power work? There are two main types of solar power technology, namely solar photovoltaic and solar thermal. Solar photovoltaic technology uses a type of semiconductor cell to convert sunlight directly into electricity. Solar thermal converts sunlight into thermal energy, which is mostly used for generating steam to drive generators and other purposes. This energy can be used to drive a refrigeration cycle to provide solar cooling. Now Xuanzhi will talk about the land use for solar energy.
Now I'll be discussing the land use of solar power, which is often criticized for requiring large amounts of flat or gently sloping land in sunny areas. At utility scale levels, it is estimated that about 2 hectares of land are required per megawatt of power. Comparing the blue and the red circles in this LCA graph, we see that ground-mounted solar PV uses land similar to fossil fuels, but roof-mounted solar PV requires significantly less, making it a more space-efficient energy alternative. So when taking New South Wales as a small case study, the AAMO estimates that approximately 20,000 megawatts of large-scale solar generation is needed to replace coal-fired power stations by 2050, which means about 40,000 hectares of land, or only 0.06% of rural land in New South Wales is needed. How and where solar panels are installed can drastically reduce the amount of land to be singled out. In this graph, we see that above-ground installations have the least land area required, which in urban Australia increases the propensity for energy generation, as they can be mounted on the roofs of existing infrastructure. This brings us to the challenges of solar power. First is its environmental impact on local ecosystems, particularly in areas with high biodiversity. It can also lead to land degradation if not managed properly. Balancing solar farm development with agricultural needs is also crucial, especially in rural areas where it is a significant part of the local economy. Innovative solutions like agrivoltaics, where solar panels are placed over farmland, can allow for both needs to be met. Lastly, large sunny land areas are usually remote and far from existing power delivery infrastructure, such as power grids or power storage facilities. Some prime solar farming land sit on privately or indigenously owned land. There is often a clash between viewing land as a resource for capital accumulation and valuing it for cultural and environmental stewardship. To circumvent these problems, we recommend effective and forward-thinking land use planning. Regarding land use conflicts, agrivoltaics offers a dual solution. Recent studies have shown that under certain conditions, these systems can boost crop yields compared to traditional farming. Globally, government funding has rapidly advanced agrivoltaics. In Australia, state-based schemes could further incentivize the use of agri-solar beyond pilot projects. With all these in mind, we now look at solar power's carbon emissions, which will be taken by Mei Yi.
Hi, my name is Mei Yi. I'm going to talk about CO2 emissions of solar energy. The government reports indicate that emissions for the year to March 2023 in Australia are estimated to be 465.9 million tons of CO2 equivalent. Compared to the previous year, emissions are estimated to have increased by 0.3, including ongoing reductions in emissions from electricity, down 3.9% as renewable energy uptake continues to displace fossil fuel power sources. The current carbon footprint of solar panels occurs at every stage, but is mainly concentrated in the early stages of manufacturing and installation. Firstly, the extraction of raw materials and production generates CO2 emissions. Subsequently, transport vehicles generate CO2 during transportation. Finally, the tools and vehicles used for installation, maintenance, and of life all generate CO2 emissions. In order to verify that the solar system can achieve carbon positivity, Yu and other researchers study and analyze the impact of solar energy consumption on CO2 in 10 countries. The results shows that solar energy consumption in Australia is negatively correlated with CO2. That means SEC can improve the environmental quality in Australia. Meanwhile, the IEA reports that the carbon footprint of solar power is 10 to 20 times lower than that of coal. Over its lifetime, solar PV is estimated to reduce greenhouse gas emissions by around 90% compared to coal. In order to study the CO2 emissions from fossil fuel power generation and PV power generation respectively, Mr. Yu and other researchers conducted a life cycle sustainability assessment of a PV solar cell, or called UQ solar. The results of the study show that the CO2 emissions of the PV system are much smaller than those of the conventional grid power system. So in conclusion, all in all, it's just that energy efficiency can be improved and carbon emissions reduced in the future. For example, by increasing the life of solar panels to achieve near zero emissions in Australia by 2050. So Australia is a country with strong solar energy. Shihui will talk about the feasibility of solar energy in Australia.
Hi, this is Shihui. I will talk about the first part, feasibility in Australia. In Australia, there have some policy support, like renewable energy target, solar feed-in tariff. This allows households and businesses that install solar energy system to sell excess solar power back to the grid and receive corresponding buyback compensation. In addition, solar energy technology is gradually maturing, and the cost is also decreasing accordingly. Compared with the traditional fossil fuels, solar power generation produces almost no greenhouse gas emission and is an important means of driving climate change. And also, solar energy system can be installed in a distributed manner, which helps to improve the stability and the safety of power supply and reduce reliance on centralized power facilities. And also, Australia have enriched solar energy resource. The average annual sunshine hour in many regions of Australia exceed 3,000 hours, especially in inland area and western desert regions such as Alice Springs and Perth. Well, according to the above, it seems that the implementation of solar energy in Australia is very feasible, but the initial cost discourage many families. For example, if the initial cost of installing a 5 kilowatt solar panel in a household is between $4,500 and $8,000. Fortunately, the cost recovery rate of solar panels is relatively fast, around 3 to 7 years. Moreover, with the rise of in electricity bills, solar energy can help households and businesses save a significant amount of electricity expenses. Well, now, let's summarize today's presentation.
Our presentation discussed the solar energy in Australia. Firstly, as a clean and sustainable energy option, solar energy has important advantages in terms of environmental protection and future energy security. What's more, installing solar panels on the roof reduces the amount of land needed and increases the possibilities for energy production. Placing solar panels on top of farmland can balance the development of solar farms with agricultural needs. Thirdly, throughout its life cycle assessment, solar energy has a significantly low carbon footprint than fossil fuels, making it a key factor in reducing global carbon dioxide emissions. Finally, Australia's possible support maturity and cost reduction of solar energy technology, abundant solar energy resources, and environmentally friendly characteristics. These factors demonstrate the feasibility of solar energy in Australia. Here are the references we used in this presentation. Thank you for watching.